Hello and welcome to week 3 of Signs and Symbols, Enhancing Science Instruction Through Literacy in the MCCS era. This week we'll be talking about Common Core in the science classroom. And the intent of this section is to familiarize you with the language of the MCCS for ELA and literacy in science. And we're hoping that this video can be a supplement to the other videos that we have you watching for this week. So Common Core represents a very positive reform in education that focuses on preparing students for college and careers and does so with fewer, higher, and clearer standards than we have previously had. However, it is an era. Good instruction came before the Common Core and good instruction will come after. What we want you to see is that good instruction matches the Common Core, and when we are using best practices in science instruction, we are aligned to the Common Core. In order to do that, we need to become a bit familiar with the standards themselves. This graphic gives you an overview to the structure of the MCCS ELA standards. In pink, you see the 4 strands: reading, writing, speaking, and listening, and language conventions. In the next layer, you see some categories within those strands. For example, in reading, we have strands for literature and for informational texts. Within the writing strand, we have standards for writing 3 different types of text: narrative, informative, and argumentative. Our focus has really been on the reading and writing portion of this, although speaking and listening and language conventions definitely play a large role and an important role in all of this. You will notice at the bottom that there is a box for content area literacy. In grades 6 through 12, there is a separate set of standards that provides guidance for teachers in science, history, and technical subjects. These standards are for reading and writing. The way that the CCSS, or the Common Core State Standards, were written is important to understand. They used a backwards design. They started with what a student should be able to do upon graduation in order to be successful in college or in a career. These are the college and career anchor standards. Once these anchor standards were written, they work backwards from grade 12 to kindergarten. There are anchor standards for reading and writing. In writing, the topics are text types and purposes, production and distribution of writing, research to build and present knowledge, and range of writing. In reading, there are key ideas and details, craft and structure, integration of knowledge and ideas, and range of reading, and level of text complexity. These topics are consistent through all grade levels. The anchor standards themselves are numbered 1 through 10 for reading and 1 through 10 for writing. And again, this number is consistent from grade to grade. So the organization of the standards provides clear vertical alignment and makes it relatively easy to navigate through the standards. We can summarize the way in which these standards are different from previous standards with 3 key shifts. Remember, these shifts represent the difference between the standards. Many teachers who were using best practices were doing these things before the Common Core. Shift 1 is building content knowledge through content-rich informational text. This is often referred to as just informational text. So again, the emphasis that I'm sure you'll hear in the other videos as well on this idea of using informational texts and being able to read them proficiently. Shift 2 is a spotlight on text complexity and academic vocabulary. This is often referred to just as text complexity. Shift 3 is reading, writing, and speaking based on evidence from text. And again, that highlighting that idea, which obviously is very important in science as well, but what evidence are you taking from the text to support your argument or your claim? So the following slides will highlight some of the key ways that the standards build upon each other from elementary through the high school grades that are particularly important for science education. So within the strand of reading, again, we have these overarching big themes in the anchor standards: key ideas and details, craft and structure, integration of knowledge and ideas, and range of reading and level of text complexity. And so what we'd like to do is for each of these, just kind of taking you through some of the things that we feel are maybe especially important to consider when we're teaching in science or technical subjects. For range of reading and level of text complexity, basically what it's saying is that a student should be reading at a level appropriate to the grade that they're in. So we're not going to spend much time on that, but we're going to break down the other three in terms of, again, things that might be especially relevant to the use of text in science. For key ideas and details in reading, we've picked out some of the important aspects in K through 5, 6 through 12, and then the science-specific standards, which again were written for students in 6 through 12. Obviously, these build upon one another, so things that are happening in K through 5 would also be happening in 6 through 12 with the additional aspects such as citing appropriate evidence. Science are things that have been identified as particularly relevant or important for working in the domain of science, such as using correct terminology and symbols. Again, these are developmental, so for example, in K through 5, identifying big ideas in a text and supporting details, a kindergartner looks much different than a fifth grader in doing that. And so the standards do emphasize that we need to be providing an appropriate level of support for helping students to do this in a way that allows them to be prepared for the next level when they move up to the next grades. Craft and structure, again, the same idea that these are building on one another. I'm not going to read through all of these on the screen because obviously you guys are capable of doing that. Feel free to pause the video to take a look. But basically thinking about how do we develop this idea of understanding how to make a text and structure it in a way that we are communicating a message effectively and also understanding with the reading aspect why a particular text was structured in a particular way in order to communicate its message. Integration of knowledge and ideas is that, understanding how to integrate texts, to compare and contrast different texts on the same topics, and understanding various ways that arguments might be constructed or how to synthesize across different forms of text or activities, things like hands-on activities and experiments with written text. How do we synthesize that information? So for writing, remember we have text types and purposes, production and distribution of writing, research to build and present knowledge, and range of writing. Again, range of writing is that students should be doing both shorter and longer term writing projects, so we won't spend much time on that. For text types and purposes, we have this build up to writing different sorts of informative or explanatory texts using different sorts of media, thinking about how to write arguments, supporting claims with evidence, and also using an appropriate style for the discipline of science. Production and distribution of writing. Again, we have that digital tools. So the Common Core standards really do focus on helping students to use digital tools to produce and publish writing. There's also an emphasis here on improving writing by revising based on feedback from the teacher or from peers, and in science, a particular focus on writing informative or explanatory texts that also includes talking about scientific procedures, experiments, or technical processes. So research to build and present knowledge. Engaging in different sorts of research projects and writing about them. Information from different relevant experiences. So again, things like hands-on activities, maybe simulations, that ties into that whole multiple sources piece. And then moving on to a focus on self-generating questions. And then in science, again, where appropriate, including data from our hands-on experiments, so that idea of emphasizing the importance of data in science. Speaking and listening, we don't have science-specific standards, but the anchor standards are comprehension and collaboration, presentation of knowledge and ideas. So for comprehension and collaboration, we really just have this emphasis on engaging in collaborative discussions with others and how to do that appropriately, how to come prepared to defend one's ideas, and how to present a point of view effectively. And even though there aren't science-specific standards for this, I mean, this obviously is really a very important of being able to do science. You don't only communicate through writing, but also through speaking and listening to others. Presentation of knowledge and ideas. Again, being able to use appropriate descriptions, appropriate details, using appropriate evidence, also using media to present information in a way that helps one to get their point across. We also need to be able to listen and to evaluate what others are saying to us. What is their point of view, their reasoning and evidence? And again, we have that emphasis on using digital media. So for language, so the anchors are conventions of standard English, knowledge of language. Obviously, those are important in any kind of writing. One of the big ones important in science is vocabulary acquisition and use. Specifically, I think the understanding of scientific meaning of words. We can think about things like work, energy, efficiency, things that we use in everyday life that have a different meaning when we're thinking about them in a scientific way, right? So helping students to understand the scientific meaning of these words. And this has been something that I've found in my own research that can be difficult, at least for middle school students. Also, being able to gather knowledge about important, unfamiliar vocabulary. So if I don't know what a term means, how do I go about finding out what it means and how it's being used in this context? Finally, I just want to end with some connections to digital texts, as you saw throughout our discussion of the Common Core standards, and this is also something we highlighted last week. I know that many of you discussed that there are access issues with getting access to computers and other digital resources. So something that we will add, as Chris had said, is thinking about how we might facilitate the use of these resources in groups. But I think this is really important to highlight, given that the Montana Common Core standards refer to looking at a range of texts and also diverse media formats, and digital texts and other digital resources are some of these diverse resources that are referred to. So here are a few ways in which what we talked about is related to the Common Core standards. This idea of locating relevant information, how do I evaluate the results, evaluating credibility and accuracy, synthesizing across sources, communicating with technology, how do I produce and publish, how do I collaborate with others, and then even participating in communities online. How can I create resources for others and interact with others in order to learn science and communicate my findings? So these are some really cool aspects too of working with digital texts, and obviously things that our learners are going to be required to do in their future careers or when they get to college. So hopefully this has been helpful as you move forward and do the activity to think about the Montana Common Core standards, and also thinking about how to apply them effectively in your classroom. Thank you.